Hey, this is Sam Singer along with my partner PJ McFarland, and this is our Varignon Frame Minecraft version. Now, this is for our AP Human Geography teacher, Mr. Strogo. We're in his third period class. And based off a mathematician's idea, Pierre Varignon, the Varignon Frame is a model to show geographers the optimal location for a factory or industry based on the transportation costs of the raw materials and the final products being transported to the market.
Okay, so here's how it works. We have 4 castles. 3 of them are going to be raw material sources, and 1 of them will be the market. We'll say red is the market. And we'll use the steel industry as an example. Yellow will be carbon, blue will be iron ore, and green will be coal. This diamond block here at the bottom represents the factory. Right now it's at the middle because all the transportation costs for all of the raw material sources are equal. But if we go over here and we turn up iron ore to tier 1, light goes on, and the factory moves a little bit closer to the iron ore raw material source. This is because the transportation cost is now greater. The factory is going to want to be closer to accommodate that. The transportation cost for iron ore is currently at 1, but if we were to change that by turning off that switch, resetting, and increasing it to 3, now you can see that the factory is much closer to the iron ore raw material source because the transportation cost has tripled.
Okay, so now if we want to try the coal source, so we're going to go to the green aisle, turn off those, reset. Now, let's just try the cost of 1. So we're going to turn on tier 1. We're going to look where our industry is now. The light's on over there, and it's 1 notch closer to our coal source. But now if we go back to our board, and we triple the cost, well, we have to reset, of course. We triple the cost. So now that light turns on, and the transportation cost between coal and our factory is much greater, so we move the factory much closer to the coal source.
Now we're going to look at the transportation costs for carbon. Let's turn off this, reset, and now turn on tier 2 for carbon. So now the transportation cost is 2, and it's a moderate distance away from the center and the raw material source for carbon, about in between. And if we turn off tier 2, reset, and turn on tier 3, then it's a little bit closer because now the transportation costs are again increased. Yeah.
We're just going to look at the transportation cost between our market and our factory, which for some industries this is the most important. And so we're going to turn on, we'll reset, we're going to turn on tier 1 for the market. And as you can see again, the light is on, and it's just moving just a little bit closer because the cost between the market and the factory are just a little bit more than the cost between the raw material sources and our factory are a little bit less. So, gotta turn off tier 1, reset, and we'll just try tier 3 again. And as you can see, our factory has moved even closer to the market because the transportation costs between the two have tripled.
Now we're going to briefly take a look at how everything works. So this switchboard is hooked up to, well, each color is hooked up to 4 command blocks, and each one performs a specific thing. One of them turns on the light, one of them makes sure that the light is off when the switch is off, one of them gets rid of the diamond block from the middle, and one of them puts the diamond block wherever its specified location is. Over here, we have the reset switch, which gets rid of any possible area the factory block can be, and it also resets it to the middle. In conclusion, the Varignon Frame model helps geographers find the ideal location for their factory based off the transportation costs between the raw materials and the market. Thanks for watching! That was a slide whistle.